Hey guys, welcome to the third video in this Flame game development series where we are making Ski Master, a top-down vertical scroller about skiing. In the last video, we used the router component to set up the whole UI flow for this game. And we did this by using overlay routes for the main menu, settings, level selection, pause menu, level complete and retry menu. For the actual gameplay, we used a normal route since gameplay is made up of Flame components. This basically allows us to select levels, pause and restart them if needed, and change some in-game settings. So in this video, we are going to create our own level and do some camera setup to render the level correctly. But before we do that, I'll upgrade the Flame packages, because a newer version of Flame got released since the last video and we no longer need to depend on the main branch. So in the bub spec, I'll remove the dependency override section and change Flame version to 1.10.0. And while we are at it, let's also upgrade Flame Tile to 1.15.0 and save this file. Okay, now we can start working on the level creation stuff. For that, let's open the tiled editor. As you can see, the sample map and tile set are already open for me. Tiled allows us to create, open and edit individual tile maps and tile sets just like that. But for this project, I'd like to show a more streamlined approach for tile map creation. We'll start by creating a new tile project by going to File, New and then New Project. And since I want this tile project to be part of the same GitHub repository as the main Flutter project, I'll create a new folder in the project root called tiled. And then I'll just change the project name to Ski Master and save this. Note that this project location is totally up to you and does not necessarily have to be placed at the Flutter project root. Okay, so to begin the tile map creation, we'll first need to create a tile set file. And to explain what tile sets are, I'll let DevKage from the past do the talking. So the two important file types that you can create in tiled are tile maps and tile sets. Basically, the way tiled works is you create your levels using some predefined tiles. Tiled then stores the coordinates of each tile from that level in a tile map. And information of each tile is stored in a tile set file. Simply put, tile map is the file that actually represents a level, and tile set is a file that holds all the tiles that can be used in a level. So to create a new tile set, let's go to File, New, New Tile Set. This will open the new tile set creation window where we'll have to select a source image for this tile set. I'll navigate to the assets/images folder of my Flutter project and select the tilemap_pack.png as the source image. Doing so will automatically populate the name for this tile set. The only thing we need to change is the tile width and height, because sprites in that image are 16 by 16 in size. Once that is done, we can save this tile set in the tiled folder. And if you did everything right, your tile set should look something like this, with each tile perfectly fitting a 16 by 16 square. Next, let's create a new tile map by going to File, New and then New Map. On this window, you'll get some drop-down options to select the orientation, format and render order of this map. The default values should be fine, but just double check that your options match the ones shown here. Next, in the tile size section, make sure that the width and height are set to 16, just like it was in the tile set. And finally, the map size section defines the width and height of the map in terms of number of tiles. Since this game is going to be a vertical scroller, we would generally want the height to be larger than the width. So let's change these values to 20 and 40 respectively. In case you are wondering, these values don't have to be perfectly accurate. You can easily resize the map according to your needs once you start editing it. Now what you see here is an empty map with this grid. Each cell in this grid is a 16 by 16 square which can be filled with tiles from a tile set. All the tile sets will normally appear in the tile set section located at the right side. But I think the tile set needs to be opened for it to show up here. So let's double click on the tile set from the Project Explorer to open it. And yes, Now we can see our tile set in this panel. Now placing tiles in the map is as simple as selecting it from the tile set and painting it on this grid. This tile placement is using the stamp tool right now. But you also have access to other tools, like the bucket fill tool, which can fill all the empty cells with a particular tile. So Tiled also has a layering system, which allows you to manage a complex map into several different layers. And there are 4 types of layer that Tiled supports: tile layer, object layer, image layer, and group layer. Tile layer is for painting tiles, just like what we saw right now. And you might have noticed that Tiled creates a default tile layer for every new map. Object layer is for placing metadata about objects that we can parse in the engine. Image layer is for when you want to render a single big image as background or foreground. And group layer is for storing other layers as its children. It just helps in organizing the layer hierarchy better. Okay, so I'll rename this tile layer to path because I want to store just the skiing trail on this layer. And now I can start creating the path. Since this is going to be the very first level, I want it to be easier. So I'll keep it simple with constant width throughout and just a few turns. And notice that I'm trying to keep the trail roughly around the center of the map so that we can place some trees and bushes around it later. Also, notice that I am not filling the surrounding parts with the white snow tiles. This is because I'll be setting the background color of the game to match the snow color. So painting the snow tiles is not necessary. I'll encourage you to create your own level to get comfortable with tiled. But if you are not interested in level design stuff, you can grab the level files from the GitHub repository linked in the description. Okay, now that the skiing path is ready, I'll create a new tile layer and rename it to decoration. On this layer, I want to place some flags at the start and end of the skiing trail. Although I am placing them at the extreme edges of the map right now, we'll probably change them to be at some offset from the edges as shown in the initial demo videos. Next, I'll start randomly placing some trees and bushes around the trail. Now Tile does have tools to make such random placement much easier and quicker, but that requires some setup to get it working properly. So I won't cover that here, but if you are interested, you can read about it in the Tile docs. Okay, I think this looks good enough for now. So let's save this map in the tiled folder as level1.tmx. In the past, I used to use this same tmx file in the game to load the levels. But then I realized that Tiled has an export option under the file menu, which allows you to export in tmx format. And probably this exported tmx is what we should be using in the game. For the most part, both the files look identical, but if you go to Preferences under Edit menu, you'll find this Embed Tilesets flag in Export Options. If this option is checked, the exported tmx gets modified to contain the data about tilesets. This eliminates the need to ship an external tileset file. So for this project, make sure you have this option checked in your preferences before exporting the map. And while exporting, make sure to save the exported map in assets/tiles folder of your Flutter project. Also, double check the file name to remove any additional dots from the file extension. Now back in the project code, I'll go to the gameplay class and modify tiled component to load level1.tmx instead of the sample map. I'll also change the destination tile size to 16 by 16. Okay, and as you can see, we now have the level 1 rendering in our game. It looks too small and is sticking to the top left corner of the application window right now. But the camera setup that we'll do later in this video will take care of that. So before we start setting up the camera, let's delete the sample map and related files from the assets because we no longer need them. Okay, now although we can see the tile map rendering in the game, it does not look great. Moreover, once we add the skiing character, we would really just want to see parts of the level around the character as it moves. This would mean we'll have to manually transform the tile map to make it seem like the character is moving in the level. This can get out of hands quite quickly if not done right. But luckily, Flame offers quite a powerful camera system to make our lives easier. You can find the details about this under the camera component section in the Flame docs. Unfortunately, even after reading the docs, it can be a bit difficult to wrap your head around the camera system. In my opinion, this is partly because the old camera system was easier to use even with its limitations as compared to the new system. And the other part of the problem could be that, unlike other engines, Flame does not have a graphical editor. This means all the camera movement that one would do using mouse and an editor needs to be done using code in Flame. This makes it a bit tricky for beginners to grasp the camera concept in Flame. I'll try to bridge that gap here and try to explain the overall concepts behind the new camera system. So this new system has two major components, the world and the camera component. World is where you set up all the components that are part of your game world. In our case, this will include things like the tiled component, player, and collectibles. Essentially, world is just a root component that stores all the gameplay entities. And to look at or render this world on the application window, you need a camera component. It is roughly equivalent to a real-life camera that you can move and rotate to look at a particular subject. Now, how this world looks when seen through a camera depends on two important components of camera, the viewport and the viewfinder. Explaining these two components in words is quite tricky. So I'll use an example to showcase the concept behind these two components. For that, let's go back to the tiled editor. Here, you can see that the map is displayed in the middle section of the editor. This middle section is what the viewport component represents. Basically, it is the area of your application where the camera can render stuff. Anything that goes beyond the viewport size gets clipped and is not rendered. And this moving and zooming of map that I am doing, it is controlled by the viewfinder. So the viewfinder controls what and how much of the game world gets rendered within the viewport. Again, if I move the panels on the left and right of the viewport, that will actually resize and reposition the viewport. But if I drag the map around and change the zoom, that controls the viewfinder's position and size. So as long as you can understand the things that these components control, you will be able to make sense of the camera component. Okay, now let's go back to the code and try to set up a camera. Since our level loading happens in the gameplay component, it makes sense to set up the camera system in that class. But before we do that, do note that Flame Game does provide a default camera component and world as direct child of the game class. It might be making things easier for some games, but not all games need the camera and world to be direct children of game class. Also, depending on the type of game, one might need multi-camera or even multi-world setup. As an example, in this game, we might end up setting a secondary camera for debugging purposes. Due to these reasons, I'll be completely avoiding the default camera and world that Flame Game provides. So in the onload of the gameplay class, I'll first create a new world. And instead of adding the loaded map to gameplay, I'll add it as a child of world. Note that world is a component too, and providing a list of children component is as good as manually adding them to the world by calling world.add or world.addAll. Next, I'll add this world as child of gameplay component. Now, just doing this won't actually render the world. For that, we'll have to create a camera component and make it look at the world we created by setting the named world parameter. And finally, I'll add this camera to the gameplay class as well. Now let's run the game and test this. Okay, so we can definitely see the map on the screen. It still looks small, and this time it is closer to the bottom right. So if I try to resize the game window, you'll notice that the map does not scale, but it does change the amount of map that is visible. This is not ideal for this game, because this would mean people with bigger screens will be able to see more of the map and will have some unfair advantage over others. As a game developer, our aim should be to avoid such unfair advantages as much as possible. So in this case, it would be best to render a fixed size of the map irrespective of the screen size or the application's window size. In a more technical speak, we want the viewfinder to transform such that it always shows a fixed amount of world irrespective of the viewport size. And we also want the viewport to maintain a fixed aspect ratio irrespective of the application's window size. Lucky for us, the camera component has a with fixed resolution constructor that does exactly what we want. This needs a width and height which should be equivalent to the amount of world that we want to display. So let's set the width and height to 640 and 360 and then hot reload the game. Okay, now the size of the map does not seem to have changed much, but if I try to resize the game window, you can see that the map scales correctly to always show a constant size. Also, notice how the map is getting clipped at the bottom. This is because the viewport is trying to expand as much as possible while also trying to maintain the aspect ratio of the resolution we provided. In doing so, it clips out parts around the vertical or horizontal edge when the aspect ratio of window size does not match the aspect ratio of the viewport. Generally, this results in black bars around the game. Next, to make the level a bit more zoomed in, let's lower the resolution to 320 by 180. Okay, now let's address the elephant in the room. Why the map seems to have been moved to the bottom right. This is probably one of the most confusing things that people encounter while using the camera component. And the things that they do to make it look right generally makes things even more confusing. So I'll just start by saying that this output is perfectly fine. In fact, this is what you should be expecting if you read the docs about Viewfinder. To explain this, let me set the debug mode property of tiled component to true. Setting this to true makes Flame render some debug information about the component. So with the debug mode on, you can see that the top left corner of the tiled component is actually at 0, 0. This makes perfect sense because tiled component is derived from position component. Position component by default are placed at 0, 0 of the parent component that they are attached to. And default anchor point for all components is the top left corner. But then the next question arises. Why 0, 0 is at the center of the screen? This happens because what the camera is looking at is defined by the anchor point of the viewfinder, and the default value of anchor for the viewfinder is center. This makes sure that whatever the camera is looking at, it stays at the center of the frame. Since we haven't given any target point to the camera, it is just looking at the origin. And since all the tiles of the map are on the bottom and right section of the origin, the camera has nothing to show for rest of the area. Hope this helps in understanding why the output is perfectly valid based on the camera setup we have done so far. And to fix this, you absolutely don't have to mess around with anchor point of any of the components. I've seen people change the anchor point of viewfinder or even the tiled component to make it look correct. It might look fine initially, but if the camera is supposed to follow a component, these anchor changes will start showing more confusing behavior. Okay, enough with the rambling. Now let's move the camera a little bit towards right and down. I'll do that by calling the move to method on camera with target position as 50, 30. And after the hot restart, you can see that map has shifted a little bit. Similarly, you can set it to look at the center of the whole map using map.size times 0.5. The initial position of camera will ideally depend on the start position of the player character. But for now, let's make it target the top center of the map. And that will be half the width of map, 0. Okay, and again we'll have to move the camera a bit downwards so that the level start is not at the center like this. And to be precise, we just want to move the camera by exactly half the height of our fixed resolution. But to avoid hard coding the height value here, I'll fetch it from the virtual size of camera.viewport. And that should do it. Now we have a much better initial position for the camera. Next, let's take care of the background of the map. For that, I'll go to the game class and override the background color method. Here, I'll just return a custom color using the RGB values from the snow tiles. And you can already see how much better this looks with the background color. I'll also quickly change the material app in main.dart to hide the debug banner. Now the scaling and clipping is working fine. One thing I'll quickly point out is that if you are planning to make this game for mobile platforms in portrait mode, then this setup will basically make the game unplayable. You can clearly see that with a mobile-like screen size, the game gets clipped too much along the height. This happens because in portrait mode, the width is smaller than the height of the screen. So you might want to consider swapping the width and height values in the fixed resolution camera. This simple change will already make the game look much better on mobiles. And if you want to avoid the clipping without giving that unfair advantage, you can fix either of the dimensions and calculate the other one based on the aspect ratio of the device that your game is running on. Flutter already gives you very simple APIs for getting the device screen size and aspect ratio. Okay, I'll roll back the width and height changes because I'm mainly targeting this for desktop. Once the whole thing gets completed, I might create a single video covering all the changes that will be needed to make this work as an Android game. So yeah, that is it for this video. We didn't make a lot of code changes, but I hope the explanation about the new camera system and related components helps you, or at least some of you. But yeah, if you enjoyed this, hit that like button, consider subscribing the channel to show your support, and I'll see you in the next one.